Welcome to my channel Sir Roy Physics. Today lecture 3, topic force and motion. Topic is idea of momentum. Suppose there is a taxi moving with 200 meter per second and truck moving with 200 meter per second. Both, if we apply brake, and stop in 10 seconds, then force required for track, force applied on track greater than taxi, because momentum, very important vector quantity in for motion. Momentum, that is mass into velocity, is more for track. That means momentum is the fundamental vector quantity in motion. P, that is equal to m into v. It is a vector quantity momentum. So if you apply force is applied, means momentum will change. Now force equal to momentum equal to mass into velocity. In classical mechanics we assume mass equal to constant. So force, generally force acting, that is unbalanced force acting now. If force equal to 0, means momentum equal to constant. Sometimes force, according to Newton's second law, proportional to rate of change of momentum. Now from second law, rate of change of momentum is directly proportional to force, and momentum change takes place along the direction of force. So we have F equal to K m v minus u by t for unit force, F equal to 1, m equal to 1, and that is the acceleration k m into a, where a is the acceleration v minus u by t. So you are getting F equal to k m into a for unit force, m equal to 1 causes acceleration 1, that is k equal to 1. So we have force equal to mass into acceleration. Now another things I am telling, force equal to change in momentum by time, or F into t equal to change in momentum. Change in momentum is called impulse. m into v minus u, that is impulse. Change in momentum equal to impulse. Impulse is the force and action of force. Force and action of force. Now we should write suppose a body moving with velocity mv along this direction, when coming back it is minus mv. Change in momentum equal to mv minus mv to mv, that is impulse. Now impulsive force is huge amount of force acting for a short duration and causes huge change of momentum. As for example, when you are striking a ball with a bat, time of contact is very minimum, but bat produces huge change of momentum for the ball. Hammer and nail, if we strike a nail with a hammer, time of contact with the hammer and nail is very minimum, but huge momentum for the nail take place. So impulsive force is the huge amount of force acting for a very short time and causes huge change of momentum. Now there are some practical example I am telling you. Newton's second law I have already told you that force equal to d by dt on, or you can write delta p by delta t. What is delta p? Very small change in momentum. By time, very small time, delta t tends to 0. That means force can be written delta p by delta t, or you can write force equal to m constant delta v by delta t. You know, in higher class you will get dv by dt, rate of change of velocity, that is equal to acceleration. In class 11 you will learn this. Now you are getting mass constant, that means velocity of the particle change will be very less than velocity of light. As a result, m is constant. So from Newton's second law I can write delta p by delta t, delta p equal to mass into delta v by delta t. Here mass is constant, so delta v by delta t acceleration. So we write force equal to mass into acceleration. Now unit of force is Newton. 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 Unit of force Newton SI system, and unit of force equal to dyne CJ system. 1 Newton equal to 10 to the power 5 dyne. So whenever unbalanced force acting, there is change of state. If the force and motion in the same direction, if the force and motion same direction, then velocity will increase. That is accelerating force. Velocity will increase. But suppose force acting against the motion, velocity reduced, gradually velocity reduced, and ultimately body will come to rest. As for example, when you are applying force F on the body M, there is a friction force against the motion. Different types of forces we shall deal in all chapters. Some are contact, some are non-contact, gravitational force, electrostatic force, magnetic force, that are non-kinetic force, we shall discuss gradually, and some are contact force. Whenever force is there, there will be change of state, either rest to motion or motion to rest, or the body may be deformed under the force when you are applying force on the body. After that, we shall resolve the force or different resolution. That means parallelogram law of vector addition. Two forces are acting. As for example, this is common formula. I am using resolution suppose two force F1 and there is a F2. If we add by parallelogram law of vector addition, first to complete the parallelogram, angle is theta, acting at the A, B, C, D. Now resultant of this force is R or F, making angle alpha with F2. That means vector addition, by vector addition I shall discuss vector addition of force. What is this? Two forces are acting on the same particle A. If you take the diagonal AC, that is the force will be F1 square F2 square twice F1 F2 cos theta. That is the magnitude of the resultant force. Resultant force F equal to F1 F2 square twice F1 F2 cos theta. Now if theta equal to 0, then F force will be F1 plus F2. If theta equal to 180 degree, you know cos 180 degree equal to -1, so F minimum will be F1 minus F2. As for example, when you are swimming along the stream, then F1 net force F1 plus F2, but when you are swimming against the stream, then it will be F1 minus F2. This is very important. Now another some example I am giving you. Suppose an athlete, by vector addition of forces, what I am getting? F1 and F2, two forces acting at the point A. Suppose these are two adjacent sides of parallelogram. Now we complete the parallelogram. Diagonal of this parallelogram will given by this formula. We are getting this formula can be derived in class 11, and theta. Now what will be the since velocity force is a vector quantity, So naturally we cannot add f1 equal to f2 equal to like this. So we have to add by vector method. So by vector method, parallelogram law of vector addition I am using here. F equal to root over f1 plus f2 square to f1 f2 cos theta. This is done as for example in the case of bird. In the case, suppose bird, a bird by wings producing, giving action, and in this way it is resultant force by bird, it will go up. Now I shall do some numericals. So Newton's second law, one example I am telling, already I have got force equal to mass into acceleration. Graphically, how can we write? Graphically, acceleration and mass will be like this. When force equal to constant, but force and mass will be like this. Here acceleration constant, another one force and mass, that is force and acceleration. Force and acceleration, it will be like this, mass constant. So this is the following graphs we should follow. Another example of impulse, I am giving some practical example impulse. Suppose with the help of f equal to ma, the following graphs can be drawn. So graphs are given like this. So graphs. Now if there are two balls, one is 10 kg, other is 2 kg, for the same velocity 100 meter, both are rest meter per second, force F2, there is applied force F1. Here F1 must be greater than F2. Inertia is high, 10 kg, that is 2 kg. So velocity will change 100. Both cases it is initial velocity 0, final velocity 100, final velocity 100. Now both cases velocity change is 100 meter per second. So in that case F1 is greater than F2. Similarly, restoring force, whenever a spring is applied by force like this spring having spring constant K extended by x, then force equal to minus kx. Why minus? Because spring is elongated along downward by restoring force acting upward. Now from our previous lesson or lecture, we shall do some numericals based on some of the equation. I am doing one by one 3 numericals with you. Now numericals on motion, and you are getting next video 2020, that will be third law and numericals. It will be lecture 4. All children, that means if you follow 14 to 24, I am going to teach you third law and some numericals and example from some second law, application of second law as well as from third law. Today now I shall spend my time on numericals based on motion given by the formula. Let us rub the board. First problem is displacement at each second. Already I have told you u plus a by 2t minus 1. That formula is used to find out displacement at each second. Now what is given? Suppose a particle moves in 7 seconds. Particle moves in 7 seconds 20 meter, 9 seconds 24 meter. Then what is u and what is a? So this formula 2 times used. First case 20 meter equal to, first case 20 meter, you are getting u plus a by 2 13. Why? Because 2 into t, 2 into 7 minus 1, and you are getting 20, that is equation 1. You are getting 20 plus u plus 13a by 2, equation number 1. And already 9 seconds, how much the particle has gone? 24. So you are getting 24 u plus a by 2, 2 into 9 minus 1, or 24 u plus 17 a by 2, that is equation 2. That means what is the problem given? This is the formula. I am using this formula. So when you are doing numericals from class 9, all children, I am telling you, you give trace on numericals. If you be confident to solve the numericals, once you do the numericals, your conception level for this subject will go up, and in near future when you are appearing for any competitive exam, especially Neet and AIEEE or JEE Main, you can analytically do all the numericals easily. So your analytical power will go up. As a result, your numerical base must be very strong from class 9. So this is the foundation course. Sir Roy Physics will teach you how to solve the numericals. So these numericals again you face in class 11. What is given? That is the 7 second 20 meter, the particle has gone. In 9 second it has gone by 24 meter. So this is the double variable equation, it will come out. 7 second, you put in the formula 20 u a by 2, 2 into 7 minus 1, and these two equations. If you solve both 2 and 1, solve 2 and 1, 2 minus 1, what you are getting? 24 minus 20 equal to, you are getting 17 minus 13 a by 2. That means you are getting 4, that case 4a by 2. So a equal to 2. So acceleration a is coming 2. Put a in any equation 1. Put a equal to t in 1. Then it is coming out 2u plus a to 13. U is coming 7 meter per second. So initial velocity of the particle 7 meter per second, and acceleration is 2. Now if they ask you what distance it will go at 15, so you put 15 means it is coming out u7 a 2 by 2, 15, that is mean 30 minus 1, 7 plus 29, that will be 36 meter. So very easy problem. What is the problem given? 10 second what formula given. So every chapter formula, derivation, unit, that is very important, and application. So physics learning should be based on numericals, unit, derivation, application. In this way I shall teach you the whole syllabus 9 and 10 CBSE board. I am trying to give trace on the foundation course so that you can be very comfortable in when you will be promoted to 11 robotic science. at the same time you will get good marks in class 9 and 10. So this is the problem. Next problem I am doing on graphical reference VT graph. Problem based on VT graph. Problem on VT graph. Problem on VT graph. Suppose this is the graph. It is plus 20, plus 10, this is minus 20, 2, 4, 6, 8, 10, 6, 4, 2, 8, 10. Now this graph is like this. Now it is coming like question is, first question, you calculate speed. First question 1, speed and displacement. First calculate ABC area, D, E, F, G, H. What is the area? Speed equal to net area, speed, area, total area, X, Y, Z. So what is the area of X? Area of X plus area of Z plus area of Y. You are getting, that is 6 and that is 20. Half into 6 into 20, it is a triangle, plus 2 into 10, 40, that is 8 to 10, 2, that is 8 to 10, and there is a height 10, plus, don't consider the sign, it will be 2, 6 to 8, 2 and 20, that is minus 60, plus 60 again. So what are getting? That is the 2, that is 2, 6 to 8, 2 and that is the 20, 6 and 8, 2 and 20, 40. Then area of that triangle, area of the triangle you consider, height is 20 and 2, that is be 20. So it will be 60 plus 20 plus 20, it will be 100 meter speed. Clear? But once you calculate the displacement, you add these two area X and Y, displacement, it will be X plus Z minus Y. X plus Z already have calculated, 60, that is 60 and 20, 60 plus 20 minus 20, so displacement will be 6 meter, it will be 100 meter, it will be, sorry, it will be distance, I am telling wrong, distance. So VT graph, that is V, that is T, VT graph, if you calculate all areas and add them absolutely, you are getting the distance. If you take the positive and negative sign, you are getting the displacement. Okay. So this is the problem on VT graph, calculation of distance and displacement. Okay. So this type of problem you may face in class 9. That means again I am telling you, graph will be given. First to consider the graph, how many areas are there, that is 2 up total area. This is the area of the triangle, this is the area of the rectangle, this is the area of the triangle. So this plus the 3 areas absolute add, you are getting distance. If you take the positive area minus negative area, you are getting the displacement. Now next is a concept on average velocity. Problem based on average velocity. Problem on average. Suppose a particle total distance is d. Suppose total distance, half of the distance gone by v1, second half gone by v2. So first half gone by v1, second half gone by v2. Calculate average. Average velocity. What will you do? First to consider this whole distance will be like this, so that it will be whole number if you divide by v1. So let distance equal to 2d v1 v2. Intelligently you would do this. If you take this 2d v1 half, then will be d v1. Half of the distance will be like this, half will be d v1 v2. Okay, second half again d v1 v2. Time for the first half, equal to d1 v1 v2 by v1. So it will be d1 v2. Clear? It will be easy for you. Second half time, distance v1 v2 by v2, cancel dv1. So both time you have got dv2 and dv1. So average velocity equal to total distance, already I have told you, total distance by total time, dv1 plus v2. So answer will be very easy, 2v1 v2 by v1 plus v2. That is the average velocity. Again I am telling you, problem is based on average velocity. What is given? A road or path is given, what data given, half of the distance gone by the passenger by v1, second half gone by the v2. You take the distance such a way so that when you are half divided by v1, it will be whole number. So I am considering distance 2d v1 v2, half distance d v1 v2, second half d v1 v2. In first half time t1 equal to distance by velocity, that is like d v2. Second half distance by velocity, that dv1. So according to concept, average velocity equal to total path, that is equal to total path already have taken by total time, add these two, then you are getting this result. Thank you all. You wait for my video for 14. Gradually every day, most probably I shall try my level best to give you video, that is Monday and Wednesday, CBC 9, and I shall give test and foundation course. So welcome to my channel. If it is helpful to you, then please subscribe and tell your friends to subscribe my channel. Thank you all.